Hello, it's David. This is my STE on the desk with its top off because I've been working on PyStorm elsewhere, but also I have decided a little upgrade is in order. My friend from the Exxos Forum, Piotr, has asked me to burn him some Dual TOS ROMs, and before I do that, before I send them to him, I would like to be able to test that they work. Here in my STE, we've seen in a previous video, which I'll link up here, I've replaced the mask ROMs from factory with these two UV erasable EPROMs, and that mostly involved changing these jumpers down here, or rather desoldering the links that were down here and fitting jumpers so that we can configure it for the different ROMs that we'd like to put in. And these are two 128K ROMs, giving us the 256K ROM that the STE uses, and we can see it's booted up nicely now into EMUTOS using these ROMs. Today, however, I would like to go one step further and fit a TOS switcher module. You've seen a similar one of these for my STFM. Again, I shall link the video up here. This one is for the STE, and it requires building completely from scratch. It's got some jumpers in there. It's got a what looks like a capacitor, I think. Yeah, and probably a decoupling cap, maybe a resistor. There we go. And I need to supply the headers. And I've also got a little socket, PLCC socket for the purpose. I'm not sure what that is. PLCC 44, I suspect, actually. Yeah, because there'll be 27C 4096s, I believe, that we're going to put in here. So that's a 512 kilobyte, 496 kilobit ROM, which then we can select. And now my friend Piotr on the Exxos Forum has asked me to burn some Dual TOS images for him, and he does have an STE, so by building this up I'll be able to do that, show you how that works, and test it before we send them back. Okay, so let's start off by taking a little look at the kit. As I say, we've got a PLCC 44, I think it's 44, socket here. We've got ourselves a jumper, we've got ourselves a capacitor, we've got ourselves a resistor, and we've got ourselves a header. So that resistor, I can't, with my naked eye, make out what that says. But I imagine that's going to be a pull-up resistor. And looking at the board itself, this, by the way, this is the STE TOS switcher from the Exxos store. That's where you want to go for that. This is intended for 1.62 to 2.06, but you can put any 256K ROM images in there. That's absolutely fine, and that's what we'll be doing with multiple ones today. So we've got obviously the footprint here for the socket. We've got the footprint here for the jumper, and that says switch on it. And then we've got a resistor and a capacitor here. R1 and C1. The capacitor will just be across the power rail, I would imagine, and R1, I suspect, is pulling this this switch header, the connection header here, putting that high so that when you apply the jumper, what do you call these things? Yeah, the little jumper there. When you apply that, you pull it low, and that toggles the high bit, the high address bit of the ROM, because the ROM's 512K, STE only needs 256, so that would let you choose the high 256K or the low 256K by toggling the upper address bit. What's that going to be? It's going to be like A19 or something. Anyway, that is how I believe this works. We are given all of these parts here, and we will have to bring in some rounded, normally recommend the rounded pin header strips to sit in here where we emulate the contacts for the two existing ROMs. So these will obviously go on the other side, but I'll just measure these off, fit them here, break them off, solder them in. So let's get started, but the first thing I'm going to do is to put on the resistor and the capacitor, because those are the tiny little SMD parts, and they will be not only the easiest to do, but also the lowest profile when it comes to flipping the board around to work on it. Now, people who've seen my previous videos know that for SMD soldering I normally prefer to use a K-tip. Today I've got a chisel tip on my soldering iron, and that's because there's an awful lot of through-hole work to be doing here, and there's only 2 SMD parts, so I'm going to muddle through on the SMD bits there with my chisel tip, just because I don't want to change tips when it comes to do the through-hole components. So a bit of, where's my solder paste dried up? No, bit of solder paste across the 2 SMD footprints. Capacitor's bigger and nearer me, so we'll start with that. Tiny dab of solder on the tip. It's quite a big dab actually. Get a nice smear of flux there and hold this in place against the end. There we go. Then press down to make a nice flat connection with the board and reflow. There you go, and you heard it click as it slotted nicely into place. And the other side is just a case of tacking it down. Fair play to Exxos, the amount of time and effort it must take to tear off precisely one of these little 0805 components. Just trying to get into the damn thing is hard enough. On my head mounted loop says that that's 1002. So that's 100 with 2 more zeros on the end. So that is a 10K pull-up resistor. I don't know if you can read that there, it's upside down from your point of view. That's 1002. So that's 10 kilo ohms, which is perfectly adequate for a simple non-high speed pull-up like that. It's only ever going to change when you physically get in there and meddle with it with your fingers. So it does not need to be a low value in any way. There we go. That is 100% of the SMD work done on this board. So the pin header we could do, that sticks up quite a long way. Sorry, not the pin, yeah, well it is pin header, but you know, the jumper. You see, that's the difference in the profiles, by the way. Those are the round pin headers, which are actually quite hard to find on the traditional stockists. I tend to get mine off eBay or from the Exxos store when I'm ordering something else. And then these are your more frequently found square profile. Difficult to focus on that. There we go. They're square profile pins, you see, which are normally used for most sort of board interconnects and are absolutely ideal for the little jumpers here. The jumpers wouldn't, I don't think, go very well on the round pins. Oh no, actually, it's not terrible, but yeah, a bit of a waste to use the rounds when they're harder to come by. So I think the next obvious candidate for soldering is the socket. Now these are decent quality sockets by all reports. They're not that open backed type. I think these are actually 3M if I'm not mistaken. So these are very decent sockets shipped here by Exxos, and you see they're not open backed. You don't have that problem with a big solder blob shorting out to the pin next door. They are probably the best PLCC sockets you can get, and I'll be honest with you, most PLCC sockets are terrible, including these ones. So it is a relative term. Pin 1 is this big white dot down the bottom here. In fact, it even says 3M on the silk screen there. Pin 1 indicated on the socket by, well, a 1 and an arrow. There's also a little notch. Can you get that focus? There we go, a little notch there on the edge. Can you see that of the socket just there? so we can be confident that we've got that the correct way around. Try and align these, and we flip it over, and you just look down the edges to make sure you'll hopefully see any obviously missed pins. If something's bent and been flattened on its underside, with only 44 pins, this one really isn't too terrible. And all we'll do is we'll just dab in a little bit of flux on opposing corners, and then using a similar technique to that we saw for the SMD components, we'll get a blob on the soldering iron, much bigger blob this time because we're talking through hole, and we will just tack the two corners down. All the time I'm applying downward pressure to the board so that we there we go, so that it holds it nice and flush to the surface. And there we go, we've got a nice focus. We've got a nice flush finish, and we can now just go around and solder the others down with gay abandon. Now we'll move on to the switch connection. Now this is actually, you'd think this is easier with only two pins to deal with, but I actually find these ones harder because you can't really hold it in place and tag it very easily, because it'll either melt if you get the pins too hot. The plastic casing will either melt, or you'll burn yourself, or it's basically there's no support. So what I'm going to do is I'm going to try and squish. I can't really see that very well. I'm going to try and squish this anti-static pad that the PLCC chip came on. Oops. Going to try and squish that on it, and use that to hold it in place as I flip it over and solder on the reverse side. Let's try that again. So what we're going to do is put that there, and maybe I'll come in from just halfway. There we go. So that's lodged in there, and I'm going to try and solder that down like that, using that to give a little bit of ballast for me. I think we're going to need some flux there. Okay, that's crudely anchored. Now I can actually top it up with some properly introduced solder. There we go. It's alright. It's maybe not 100% straight, but it's if anything, it's leaning the correct way. Next up, going to be our ROM replacement pin headers. Obviously these go in the bottom. I'm going to break that off at the appropriate point. Yeah, and a similar kind of thing. It's going to be quite tricky to try and anchor this. Just going to go in the middle, I think, with one pin while I hold the other ends stable. Still easier than the just the two, because my fingers are quite a lot further away from the point of heating. But I want to try and get it as 90 degrees, close to 90 degrees as possible. Now maybe just splayed outward a little bit there, you see. So trying to put my finger on a pin that I'm not about to solder. Now reflow it. There we go. All soldered up and ready for our OS image. Let's get that cleaned up and we'll move on to the preparation. Right, so what do we need to actually burn the ROMs for use in the dual ROM changer there? Well, first of all, we need an actual ROM package. Now, these are all EPROMs. However, the modern ones that you can buy are one-time writable. Basically, they don't have the window in the top. EPROM stands for Erasable Programmable Read-Only Memory. Here is, this is quite nice, this has been shipped in a little bag here. I wonder whether this is new old stock. This is your traditional EPROM. The E is erasable, it is erasable by UV light, it has this window on the top, it has this window on the top from which, or through which you can see the die, and by shining ultraviolet light on that you can erase all of the bits in there to ones. So everything reads, you've got 512k kilobytes of FF, and then you can, using your programmer, selectively make some bits 0, and that's how you go about programming it. So these are not manufactured anymore. These are Hitachi HN27C4096. The 4096 is the number of kilobits. 496 divided by 8 is 512 kilobytes. So this is what we're using. They are in a PLCC44 package, and this is used by the Falcon, and it's used in these ROM switches that are available now from the Exxos store. This is an EPROM eraser. In here, it's very simple, in here there is a UV fluorescent tube. I've actually got a chip in here ready to erase at the moment. This says minutes up here. Take that with an extreme pinch of salt. It's just a clockwork timer, and then there's a master enable power switch here. Sometimes these will take 2 or 3 cycles of maximum. Sometimes this will only take a few minutes. Really does depend on the quality of the light, where you've got it positioned, and the quality of the chip, frankly, how old and damaged they are. If I were to throw that, it's plugged in now, so if I throw that switch, you can see the little blue light through there. I'm going to avert my gaze and open the drawer slightly. That's the UV light burning away in there, and that is how you erase these. Now, to burn them, this is by far the most common, you've seen this before, but I'll just run through it quickly. This is by far the most common thing we can get. This is branded an XGQ Pro, but everyone and their dog knows it as a TL8662+. These are available from AliExpress, from Banggood, from eBay, from all your normal sources. And these, plus a whole host of adapters, will probably set you back something in the region of £30 to £50. That seems quite a lot. It depends how many of these you're going to do. I personally have found this indispensable. It does lots of other things, not only writing ROMs and EPROMs, but also reading back GALs. I think it can write GALs. I think it can do quite a lot of programming and analysis in here. It can do tests on various chips as well if you use the Windows software. I don't use that, but more on that anon. With this, you'll get a whole set of adapters, because not everything fits into the DIP 42, I want to say. I'm not 100% sure. The DIP 42 0 insertion 4 socket that's on there. So this is the DIP 40, it's written on here. So this is the adapter I intend to use today. This one is a little bit older. It's not the current generation. It says PLCC 44 to DIP 40. Obviously that means that some pins are reused, but that's fine because they are power and non-connect pins. This is, as I say, not the most recent one. The most recent one has a jumper on here that lets you select between programming microcontrollers, PLCC44 microcontrollers, and these 27C496 EPROMs. So this has had to have a little bit of a hack. Now basically the difference between the microcontroller pinout and the EPROM pinout is very slight. Two of the pins on this side and this side are non-connect, and two of the pins adjacent to them are for ground, and this is just a case of bridging that gap. So we've just got some extra grounds. I think it's grounds, might be VCC. I've put a full discussion on how to burn EPROMs for the Falcon on the Exxos Forum. I'll link that in down below. It applies equally to this, and it explains how to do this adaptation if you have one of these older adapters. One other thing you're going to need is a PLCC puller. You can, if you are feeling particularly brave, get away with taking a small screwdriver, a small electrician screwdriver or something similar. Actually, this is probably too large, and just gently coaxing sides out at a time. I very much do not recommend that. These PLCC extractors are incredibly cheap, and in fact you can probably get it as part of the package. I would recommend, if you do buy one of these, spend the extra money. It's probably only another £10 or something, and get all the adapters that you can possibly get in one go, because buying the adapters, if you don't have the one that you want, is almost as expensive as buying the whole unit. So that is, I would say, the best way to go about things. And these new old stock UV erasable chips are available on places like eBay. Buy more than you need. Can't emphasize enough how old these are. These are mostly pulls. My friend Piotr here, who has sent these ones across to me, has got them in these little bags. These probably aren't original because they wouldn't have been shipped in plastic bags like this, and they're not HS27 FO11s. They are HN27 27C496s, so I don't quite know what that means. But they do look in fairly good condition. Certainly some of the ones that I've had before have been terrible nick, with bent pins all over the place, spots of corrosion. So definitely I would say order twice as many as you need, because I think there will be a degree of wastage involved, even if they say they're new. Yeah, all right. So what we're going to do is hook up our programmer to our laptop. We're going to fire up our virtual Linux machine, and I'm going to take you through how we're going to prepare these ROMs, test them, and subsequently burn them. First things first, let's just slot our ROM in. There is a beveled edge, there is the beveled edge, there's the beveled edge. Pin 1 is normally marked by a dot, but I don't see it on this one. But it's the way the text is oriented. So there we go. Press that into place. The TL866 TL866-2 Plus has an indication here for the pin 1 marking. So that follows this this gap here. It says pin 1 at the top there. So that goes this way around. It's a bit of a tight fit with the arm, but that should slot in and just lock into place easily there. Now let's jump across to the laptop and have a look at what we're doing. I'd like to thank this video's sponsor and the supplier of my project PCBs, PCBWay. PCBWay aren't just about PCBs either, although they are extremely good at that. They also offer component assembly, CNC machining, 3D printing, and a variety of other manufacturing services. They have a number of community-focused offerings too. The Shared Project Hub is an open platform for makers to share and exchange their ideas, and the PCBWay store is a great place to pick up assembled modules. I mean, who wouldn't want a musical Tesla coil? So many thanks again to PCBWay, and I recommend you have a look at some of the links included down below. Okay, now for starters, I know that this is a MacBook, and I'm about to show you information here on a Linux machine, but this is literally a virtual machine running in here with the 8662 plugged in and passed through, and this is absolutely perfect for our needs. There's a number of reasons for that, which will become obvious quite shortly. So Piotr's asked me to prepare 3 different ROM combinations for him. I'm going to do a few more than that because he sent me a few extra chips. But first of all, what we have is a request for EmuTOS, UK version in this case, and TOS 2.06 Super TOS. So I've been to the EmuTOS website and I have downloaded the 256K package. Piotr has an STE. The STE uses 256K ROMs. That's what I'm going to use here in my test as well. So I should be downloading the ETOS 256 package. Super TOS 206 is also a 256K ROM. So the two together will fill up our 512K EPROM here fully. I've demonstrated in my other video for the STFM how to pad the ROMs of a smaller, for the STFM it uses 192K ROMs. You pad them up to 256 and then join them together to make it fit the 512, but we don't need to worry about it in this case. So if we have a look at what I've prepared in this directory, we've got the 256K EmuTOS, and we've got the 256K TOS 206 Super TOS. So there we go. So these two can simply be concatenated. First of all, let's just prove that they work. So we'll launch Atari from the command line here. I'm going to say it's a machine STE. I'm going to say it's got 4 megabytes of STRAM, and I'm going to ask it to use EmuTOS 256 UK. And this should boot up. There we go. Perfect. Atari STE. Everything there is as we'd expect. So let's quit that, and we'll do the same thing, but this time we'll ask it to use the Super TOS. Why would I be doing this? This is just to prove that the images I have are in fact working. There we go. There's the Atari logo for TOS 2.06. So to concatenate these together, it's very simple. We use the cat command. That means concatenate. And we will do the Super TOS first. We will do EmuTOS next, and we'll join them both together with the redirect on the command line here into rom1.image. If we were to take a quick hex dump of rom1 and just have a quick look at it, we'll see that here at the start we've got 602E 0206 00 E0 0030. Now that is our normal jump command. We're indicating TOS 2.06, and the first instruction will be at E00030. So this is a 256K ROM that starts at E00000. The first instruction is at 30. So that's correct. If we were to jump down to halfway through the ROM, which off the top of my head is that 80,000 hex? No, it's going to be 40,000 hex. There we go, at 40,000 hex, exactly halfway down. You can see there was a load of FFs left over from the previous ROM. We start again, 602E 0206, that's EmuTOS's header, and again it starts at E00030. This time I can see there's the EmuTOS extended header over here on the right hand side. So that looks perfect. How can we test this joined image? This is again where Linux comes in handy. We're going to use the loopback adapter to test this as if it were a real partition. So the command we're going to use is sudo, that makes it run as root, loopback setup dev loop 0 rom1. So dev loop 0 is going to become the contents, it's going to look like a block device, it's going to become the contents of our rom1 image. That's it. So now when I run that Atari command again, if I ask it to use, well, wait, there we go. If I ask it to use TOS located at dev loop 0, we should get the first one in our concatenated image, or TOS 2.06 Super TOS. That works fine. But how can we test the second image? Well, that's actually the great advantage of the loopback adapter. So loop lo setup -d disconnects that loopback, and we can go back and set it up again, except this time we pass a -o offset 256K. We have set up loop 0 to now point 256K into rom1 image, i.e. the start of EmuTOS. So if I run that exact same Atari command again, asking for TOS at dev loop 0, this time we ought to get the EmuTOS screen. So we do. So that's a perfect test to see whether we have configured our concatenated ROMs correctly, and in this case we have. Don't forget to disconnect your loopback adapter when finished. Now, The two ROMs, as we saw in the STE, are literally physically two separate ROMs. They are a high byte and a low byte. This means when you come to program them, you have to take this image and split it so that 6.0 goes in one, 2E goes in the other, 02 goes in the first, 06 goes in the other. This is how traditionally you would do a 16-bit ROM image with two 8-bit ROMs. The 27C4096 is a 16-bit ROM. We can store this image without splitting it into high and low bytes. However, the machine I'm running on here is an Intel machine. It is a little endian device. That means that when we look at this in memory, 2E is stored physically before 60. So when I come to write it out to my ROM, I will actually write 2E60 if I write 16 bits at a time. So to circumvent that, what we have to do is to pre-swap the image. This is called byte swapping, and this is very common in the ST world. Same for the Amiga. The Motorola 68000 is a big endian chip, and more common modern chips are little endian. ARM can go both ways, but Intel is definitely little endian. So is the Z80, so is the 6502, but pretty much ubiquitous now, little endian. So how do we go about that? Well, again, we have a command line on the tool that comes to our aid, DD. This is the sort of direct block copy command. So we go DD, we go input file equals rom1.image, output file equals rom1.swp, I'm going to say SWP for swap, and we can have a conversion. Conversion equals swab, SWAB, swap bytes. There we go. 512k in, 512k out, rom1.swap, 512k. And if we now hex dump that, 2E60, 06, 02, that every second byte is swapped around. And that is perfect for now writing out to our chip. So the command we use to write out the 8662 Plus does have some Windows software. I don't run Windows, so I don't use that. I use the Mini Pro software, and I specifically have a command that I store in a shell script that does the swapping and the burning for me in one go, but I'm going to spell it out for you in detail. So we're going to run Mini Pro, and if we run Mini Pro with just the help command, this is the option it gives us. It says, or these are the parameters it gives us. So list all supported devices, W is minus W is write memory, and we want minus P, specify the device to use. There's also minus B, I think, blank check. Let's use that first. Here we go. Check for the blank. So first of all, minus P. Now in this case, I happen to know that we need HN27C496 at dip 40. Okay, I know it's not a dip 40, but bear with me. So that is our minus P, that is our package, and we're going to do B, minus B, the blank check. One of my firmware is out of date, I really need to get round to figuring that out, but there we go, the code section is blank, we can program happily. So I replace that minus B with a minus W, and we'll go for ROM, ROM1 SWP, and remembering that we are going to do the SWP. So I brought the programmer here into shot, and we can watch this go through. There we go, writing has finished and it's done the verification and we've come back okay. So perfect. There we have our burnt dual TOS image. So let's remove the chip from a programmer here. We pop the PLCC extractor in. Try and get a good view of this. and all you do is you squeeze on the extractor. You don't pull at all. There we go, it pops out, and there we are, nice and easy. Honestly, these things are worth getting. So that's our first dual TOS. That is Super TOS and EMUTOS UK. I've got a few more that I need to write out now for Piotr, so I'm going to go and do that, and then we can give these a test. Now my second ROM worked fine, but the third one I ran into some problems. I've done a blank check and that comes back fine. I tried reading out the data after the blank check just to make sure it was indeed completely blank. That dumps out fine, suggests the chip is responding properly, and when I look at the actual the data stored on the blank chip, there's all FF from start to bottom. But when I try and write to the chip, it seems to have a consistent and persistent fault. It fails after about 2-3%. There we go, gets to 3, failed, it says address 2000. So of the 5 chips that I was sent, I labelled them up A, B, C, D and E with a little bit of pencil on here, just so that I could itemise to Piotr which one contained what. And just as luck would have it, A, the first one I wrote, was fine. B, the second one I wrote, it did have a problem. I re-erased it and it worked the second time. But C, D and E, they've been through several cycles now of attempted writes, fails, erasers and trying again, and they do fail consistently. C and D seem to fail at that hex 2000 mark, which I think actually is 2000 in terms of the 16 bits addressing, so actually I think it's at 4000. So that's fairly consistent, and E fails just a short time later. I think it's at 2098. It says OX2098. So to be honest, I suspect that actually the die is fundamentally broken. I don't think they're rebadged. I suspect the problem is that actually the die's gone, but what we'll do, just for completeness, we'll get the medium strength wire brush on it and we will clean the pins. And bear in mind that these make contact with the PLCC sockets primarily on the side. The trick is obviously just to go down the side and remove any possible dirt or corrosion. Now these are pretty much clean, they look like new. Maybe that one there's a little bit, the second pin on the left might be just a little bit dull, but this will sort that out. I very much doubt that it's a problem with contacts, but belt and braces, let us try. And if this doesn't work, I shall have to apologise to Piotr and let him know that a couple of his, well, 3 out of 5 of his chips are unfortunately failed. What I was saying before, order twice as many as you need. Well, it turns out you might need to order 3 times as many as you need. Okay, so C's in, let's just run the blank check on it. Coming back as blank. Failed again, very repeatable, hex 2000. Damn it. Okay, I think we're going to have to write that one off as a bad job. There we go, blank check. Co-memory section is not blank. That has been through a lot of UV treatment, so that's probably also a sign of a failing chip if we can't erase it with plenty of UV. I can give that one more go off camera, but I think that one's dead. And here we go, E. Try this one again. Blank check. Memory section is blank. One more right attempt. that's remarkable. I think the cleaning job obviously helped there with our chip E. Brilliant. Okay, so with our ROMs freshly prepared, let's turn our attention back to our board that we've just built. This is how it's come out after a bit of a soak and a bit of a scrub. Not too terrible. I mean, it's not my best cleaning effort ever, but I'm relatively happy with that, given the amount of flux I tend to pour on these things. So we'll bring in one of our ROMs here that we've just burnt up. This one I think is UK TOS 20. No, it's UK EMU TOS 256, and it is Super TOS 206, I believe. So let's line this up again. Dot at the bottom is pin 1, and on the HN27C4096. Can't really see it here. Perhaps has it worn off? Well, anyway, pin 1 is here at the top, the way that the text is oriented. The other way to tell is that this has got a bevel just here on the top left. As I look at it, you can see that there's square corners here, here, and here, but this one's got a slight chamfer, and you can just about make that out, I think, on the socket here. You see this edge here compared to this edge here, and obviously these are the ones where the PLCC puller would fit in. So this here is the chamfer, and the dot is pin 1. So as we look at the text on the chip, the orientation of the text, it will go in this way up, following the little arrow there. So PLCCs, we just try and get the pins aligned, just roughly like that, and then just try and apply some even pressure to it to pop it in. Not quite even, but there we go. In it goes, nice and happy. So our selection switch here, I'm going to start with it on because I think that pulls it to ground. I can see a ground. The silk screen there says ground, so that should make it the lower half of of the ROM. I can't remember which way around we did it. Anyway, that should get one of them. Now, this is the bit that I'm least looking forward to, figuring out how we actually configure the STE, because well, you can see it says here, here's pin 1 indicator, but it should be located at this end, which says to me that this is not the same pinout as my EPROMs. I suspect it's the same pinout as the original mask ROM, and I can't remember the jumper settings, so might have to go and look those up. Let's bring the STE back onto the bench. Okay, so the STE is back out, and these are the 2 EPROMs we popped in last time, and the 3 configuration jumpers are just over here behind them. So first things first, I'm going to get the old dip chip puller in here, and this is one of my least favourite things in the world to do. I know some people seem to think this is the easiest thing, but I'm completely covering that up with my shadow, aren't I? Let's readjust you. Now, I've bent many a chip leg trying to do this, so I'm just going to go very gently and wiggle, wiggle, wiggle. Look at that board flex, blimey, hold that down. Just try and coax it out. There's people who can whip it out in one go, who misses. Do amaze me. Oh. I think I've got away with that. So that's the high chip, and this is the low bite. Yep, I think again, just got away with that. But look how tight that is. What I might do is spray a bit of contact cleaner in there. Uh-oh, none left. Very little left anyway. So there are 2 sockets, freshly coated, in contact cleaner, and these are the jumpers over here. So we've got link 103, 102, and can't see what that one is there, 104 I think. Now the default I believe is 232323, so that's 23, and those have been set to 12. So what I'm going to do is to throw these now to position, if I can get in there, position 23. Right, so the cutouts up here, which you can barely see because of my long range application of contact cleaner. This end up here has the notch for the pin 1 indicator. There we go. Can you see the notch on the silk screen? Just there and just there. And there is a similar notch on the socket if I run my finger across it. So that's the pin 1 end. And our board suggests that the pin 1 end is here and here. But it also says that the chip should be, or the chip replacement should be oriented in the farthest left position. So that would involve 4 pins free on both chips. Right, I'm afraid we're back into pretty terrible lighting territory over here because most of my lights are actually sort of off in that direction. So I've got my little torch involved here just to shine into this so you can see the alignment. And you can see if I put the back row of pins in there, this second row here is a little bit tight. If I line up the 2 middle rows, they don't look too bad. And this one looks pretty good. But yeah, that second row perhaps just needs to be splayed inwards. So this row here needs to maybe be splayed inwards a little bit, and this way needs to be splayed inwards just a little bit. So the way that I plan to do that, or the way that I'm going to do that, is just to get my baby pliers, and what we're going to do is just very gently tweak the pins in slightly, not very much, just a fraction. Same with these end ones, the opposite direction, just to try and encourage a slightly better fit. We don't want to bend them too much because actually we want the fit to be as snug as possible, but we do want them to be able to go in. Okay, there we go. I can feel that jiggling a bit. That's actually quite intent on sliding itself in, I think. Yep, that's sitting nicely. So here goes nothing. I shall give it a shove. That felt like pretty positive contact all ends up. Now I've got a bit of an extension on my keyboard here just to make it easier to work with, but it does mean packing the keyboard back in is slightly problematic, and I've now got a bit more material here to worry about, but hopefully this will not intrude. There we go, plenty of room, and that's nice and snug. So now I never know whether to show you the keyboard, the computer itself, the switch, or the screen when I test these. I think I'm going to gamble that you'll believe me that when the power LED goes on. And so let's concentrate instead on the screen and see whether we get any signs of life from this Dual TOS ROM as I power it up. Here goes nothing. So what we're expecting to see is this orange standby light here to turn green if we get a signal. I've got a green light on the keyboard, green light, and there we go. We've got the TOS 2.06 logo popped up. Well, that's lovely. Let's I can see that's going to be 4 megabytes from its length there, so it's detected that fine. Let's let it boot to desktop. And this is the Super TOS I think we had on this chip. So I don't know whether there's anything immediately obvious we can see from here. Don't think it says anything different there. I seem to remember Super TOS has extra arrows or something on the... here we go, yeah. That there's extra widgets over here on the scroll bars. These tabs here, now I can't remember exactly what they do. I think I've seen these before. I've got a feeling that in certain circumstances also we get 2 arrows at the bottom or something. Oh, look at that. Oh, it's real-time scrolling. Real-time scrolling, and it's changed colour when I clicked on it. That's definitely different to what we're used to. How's that going to look with the blitter on? I imagine that scrolling is going to be a little bit better, is it? There we go, a little bit more smooth, not much. And yeah, what do these do? I don't know. Huh. Anyway, this is not a Super TOS review. What I'm more interested in is, if I switch that jumper over, do we boot to EPROMs? Let's power down here. Let's remove the jumper. I'll just clip it onto one pin, so it does not make contact between the two, but that's just for safekeeping. And let's bring the power back on. Focus you. Not going to. Alright, never mind. Throwing the switch. Green light, EPROMs. EPROMs 1.2.1, Atari STE, and I think this was the UK version we put on here, so let's, sure enough, desk file view, it's all in the appropriate language. And there's our 4 megabytes. So, double thumbs up, everything working as expected. I now have a much easier OS switching expansion in the board here. If you're interested in one of these TOS switchers, they are available on the Exxos store. The populated version with the 1.62 and the 2.06 I think is more generally available, although I believe stocks are now limited because I think the ROMs are becoming harder and harder to come by, more expensive. So go and have a look if that's something you're interested in, and I thank you very much for watching today. See you next time.